Okay, today we're going to talk about key-off battery drain and certain ways to check it at the battery to see when it drains, how much drain it is, and we're going to use actually three different methods at the same time to see how they fairly close to corroborate. I have set up this circuit here. As you can look on your illustration, we're going to look at three different drains plus the normal drain of the car before we do anything. We have a 49 milliamp draw, but then we will do a 550 milliamp draw, then we will do a 5 amp draw. But the first thing we'll do is we'll check the normal drain from the vehicle. One thing I want to make out that's really important is that sometimes the drain may be the battery itself. So before we're ever in a situation like this with a customer's car, we always want to just check the open circuit voltage at the battery. And I have a suggestion is that you may want to, if you think the battery may be draining internally, as we monitor a key-off battery drain, is just take a snapshot with your phone of the battery voltage, at which your snapshot should be time-stamped, and you'll be able to look at it. If there's no pull from the electrical system in like 4 hours and the battery voltage has dropped on your DVOM, then you could start to think about the battery may be draining itself internally, and it's not a problem with the car. Just something to be mindful of. Anyway, we have three different setups here. As you can look at the illustration, I have a tool that I made that I found out that you can do this. I have a 0.1 ohm resistor, and I've hooked that in between the negative battery cable and the battery. As you can see right here, that's the 0.1 ohm resistor. It's all hooked up. I did disconnect the battery, and that's something to be mindful of depending on what kind of car you're working on. Now, in this setup here, I'm going to use three different ways to do this. We're going to current ramp the draw with a 0 to 30 very sensitive pico clamp that does quite well down to about 5 milliamps filtered on the scope. That's right here, so you can see that. And then we're gonna in the draw situations, our three draws are 49 milliamp, 550, and the 5 amp. We're gonna put a fuse. I have a 10 amp fuse. Let me make sure that is 10 amps, possibly 7.5 amp. I kind of built a little circuit here, and let's take a look. Okay, no, we got a 10 amp fuse right here, and we're gonna check the voltage drop across that fuse, because if you go online to the Power Probe site, there's something called a voltage test or a fuse page where you can actually determine with the voltage drop across the fuse that you measure across the fuse, you could determine how much amperage is flowing through there. So that's just something to be mindful of. That is also unintrusive. You can do that without having to break the connection at the battery. Something to be mindful of with that. I think you got to watch out, because some amperages, they have a tendency to pulse, that you can't just hold your DVOM there for as long as it takes just to visually look at this draw. You may want to watch it over a course of time with a DVOM to see if there's a voltage drop rise, which will tell you that there's amperage flowing intermittently through there. Something's pulsing. Just be mindful of that. So basically, we're going to go to the scope. We're on 3 channels. Channel A blue is the voltage drop across the fuse. We won't look at that first, because first we're going to just look at the normal draw. That won't be end of the equation until I hook it to the fuse box. And as you can see, current goes through the fuse, and then it will go to 1. I will only do 1 at a time of the draws. On channel B, we're looking at the voltage drop across the 0.1 ohm resistor. Ohm's law would tell us that whatever voltage drop across there divided by 0.1 ohms is the current flow in milliamps. The third channel is that pico clamp, which will be clamped around the negative battery terminal to see how much amperage is flowing. Now let's go to the scope, and let's determine how much amperage is flowing normally through the car without the loads on it. Cars have different specs. I usually say under 25 milliamps is good. So we're at the scope. Okay. Go here. Okay. And we will. Okay, I will keep the red channel off for now, because we're not going to look at voltage drop yet. I have to turn that back on. So basically right now we are looking at the, I will zoom in a little bit better. Let me get this taken care of. On our blue channel, we are looking at the voltage drop across the 0.1 ohm resistor. And let's see if we can kind of key in on that. And on our clamp, we want to get down to a much lower range, because we are looking at, now be mindful that this has a security light, which is normal for that to blink on and off, and that is normal. And once we zoom in, that'll be more obvious. You can maybe see signs of it on the, so let's kind of just let everything tone down. I'll take a few more seconds for the thing to go to sleep. Sometimes it may take a few minutes for the module to time out. Some cars take more time. So anyway, I will stop it and we will analyze it. And let's get a baseline of what normal draw is. Okay. So let's kind of, then I have it filtered. Let's look at blue, and we'll stretch it a bit. Okay, we can see they're kind of lining up together. And what I can see from this, let's take a look at the green channel. I'll put a lot of vertical stretch on there so it kind of, and pull her down. Now that is the battery light, the security light on the dash, which I know that blinks every few seconds or so. So let's go from the top of that to the bottom, and I'm gonna say about 29.26 millimeters. That's a little rough because we got such a thick line. If I went from, let's say from the here to here, we're about 18.62 milliamps. That is within, we'd call that within spec. That would be something I consider normal if I can get this thing to straighten out. Okay, come on. Okay, and as far as our blue guy, that is our voltage drop across our 0.1 ohm resistor. So let's see if we got some corroboration there. I will stretch that, and possibly we can filter that. And let's see what that would entail. And now we're going to do some math here to determine what this is. This is voltage drop across a 0.1 ohm resistor. So I'm getting about 3.9 millivolts. So basically, that divided by 0.10 is going to be about 39 milliamps. Okay, but then again, that's a rough measurement. Because we got kind of a thick line there, but nonetheless, that we consider that normal. And I would probably be more apt to trust the green channel, but actually I would trust them both. Okay, the green channel high to low, we're looking about 30.2 milliamps. Okay, let's look at how much we get corroboration. 30.2 milliamps, and on the okay, and on the voltage drop across the blue, we're looking about 3.3 millivolts divided by 0.10. We'll move the decimal to the right, and we're about 33. That's pretty good corroboration there. I could trust that. Just one thing I want to make out about key-off battery drain, why we would use the 0.1 ohm resistor method. That would be if we had a key-off battery drain that was very, very long, that it didn't rear its ugly head until maybe 2 hours after the car shut down. And we would, because sometimes amp clamps will, the batteries get low in them. We can't expect an amp clamp to hang for 2 straight hours. They're going to drift. The 9-volt battery will go down, and things like that. So that's the 0.1 ohm resistor method is really good for those long, kind of drawn out battery drains that don't happen immediately. They may happen, in the cut at 3 in the morning. A module decides to turn on, or something weird happens with a Bluetooth or something. And those are those situations where you'd want to monitor it with your scope. You take the screensaver, turn the screensaver off on your windows for your scope, and plug your scope in. I definitely wouldn't want to work on one of those. I wouldn't want one of my personal preference wouldn't be to leave one overnight. I would want to watch that during the course of the day. You'd want to keep that customer's car for the day and keep an eye on it. If you had one of those, I wouldn't wish that on anybody though. I'd rather have the drain, happen immediately, but we don't always get what we want. I'm going to start to hook up the drains now. We're going to put as you look at your illustration, you see the thing I built, and let's get that into the circuit. And we're going to start out with the 550 milliamp light, in addition to what you see on the scope right now. So bear that in mind. We got a 550 milliamps plus. If everything works out, we're going to see maybe about 580-ish. But let's see. Okay. Okay, we got our 550 milliamp light into the circuit. Everything, I will turn the scope on and we'll start to analyze. Things are going to look a little different once we take a measurement. I have to turn that channel on. My bad. Let's get her on, and we're checking voltage drop across a fuse on the red guy. So let's get the other guys back in action. Have they gone? Okay, now I got to change the clamp, right? Because I'm sorry. Let's get that to about this guy. Okay. Okay, I'm sorry. Vertical zoom. Gotta bring her back to one. Okay, we got the blue. Let's bring the blue guy back to, whoa, he's way up there. In its natural state, that's the default. Okay, so we're flowing something. We got about 550 milliamps on our draw, with an addition to what the car normally draws. We'll let it flow about a few screens. It's going across the screen, and then we will analyze it. So remember, our good draw is about 25 to 30 milliamps. That's the normal draw of the car, with the additional 550 for the key-off battery drain. So well, let's see what we get. If we're anything close to about 580, 585, we're not going to split hairs, but we're going to see something that, in a diagnostic realm, would be valuable to us. We know that's broke. 550 is excessive. But anyway, now we'll stop the scope and let's analyze. Okay. All right. Okay. All right. Okay, my blue guy, I didn't, let me do another one. Let me do it again. Okay. Here we go. Get my settings right, because I know what kind of a ballpark I'm in. My bad. Okay, now we're flowing about 550 through the draw, and in addition to the normal draw of the vehicle. And then we'll analyze. Give it one more swipe. Shut the scope off. Let's go back and give it some vertical zoom. And we'll go up 4 here. Okay. Okay. We're on top of one another. And, okay. You know what, folks? I'm going to do something a little different. I'm going to make and break this circuit. It's just a little easier to analyze. Okay. Okay. Sorry about that delay there. Okay. Okay, we're rolling across the screen. All right. Okay. Now we got something to measure. Okay, we're going to measure green first. Okay, green's going to be about, okay, let's see here, 711. About 595. That'll be 600 milliamps. Rough. That's pretty good considering the draw. The draw is 550 plus the normal draw of about 30. So I don't want to super split hairs. We know that's definitely if we had that, we definitely know that we have a draw, and we would follow that circuit through another method, maybe through thermal imaging or the voltage drop method through the fuse. Speaking of that, let's take a look at that. Let's look at the voltage drop across the fuse. Now this is the 550 milliamps flowing through this fuse. We're not gonna, the car current is not flowing through here, as you can see from your schematic. And this is something okay, we see 10.64 millivolts. That is definitely a red flag as far as current. If you went to that online, to that power probe chart, that fuse chart for a 10 amp fuse, 10 amp mini fuse, you'd see if you can just decide to do that, you can get on Google and take a look at that. If you went to a 10.64 millivolt voltage drop across a 10 amp fuse, okay, that's 10.64 millivolts across a 10 amp fuse, you're going to see around 550 milliamps. I would almost take that to the bank. Anyway, getting over to the blue, which is the voltage drop across the 0.1 ohm resistor, is going to be, where are we? That is 71. I'll see the bottom and the top. Okay, I got about 70 millivolts, okay? Now, 70 millivolts divided by 0.10 would give us about, I'm going to say, 700 milliamps. So that's a pretty good corroboration. I would probably want to get better and make a split hairs because I see that this, okay, all right, this is the entire car, again, because we are voltage dropping across the 0.1 ohm resistor. So that would be the 550 plus what the car pulls, about 30 milliamps. So on blue, we're voltage dropping about 68 millivolts, which would be about 680 milliamps, roughly. So anyway, you can see where that resistor technique is pretty accurate as far as what we can draw. So anyway, I'm gonna change up our draw, and we're gonna do a 49 milliamp draw, which is a real hair splitter. I'm going to end this video now. I'll come back to a part 2 with the QF battery drain on the 49 milliamp draw. Thanks for watching. I hope you enjoyed it, and be well. Take care.